last lab class, we set up a restriction enzyme digest so that our plasmids could be cleaved. The next step, performed by Professor Hartman, is to run the products of this digestion on a gel to determine the sizes of the products. Although we won't be doing this step ourselves, it's still helpful to know how to do it, and this video will show you how it's done. The gel is composed of agarose, which, when heated and dissolved in buffer followed by cooling in a gel mold, forms a crisscrossing jello-like matrix. DNA is loaded into wells at one end of the gel, and because DNA is negatively charged, we can use an electric field to drive the DNA toward the positive end of the gel. Because the DNA must travel through the matrix of the gel, smaller molecules will travel faster and farther down the gel, and larger DNA molecules will travel slower and remain higher up in the gel. To make the gel, we weigh out the appropriate amount of agarose powder and TAE buffer, and dump them into a glass flask. Then we heat to dissolve until the mixture is clear. Once the mixture has cooled down slightly, we can then add CyberSafe, which is a cyanine dye that binds to DNA. Our DNA samples will then fluoresce with a bright green color when excited with UV light. We then pour this into the gel mold, pop in the comb to make the wells, and wait until it cools and hardens. Once completely solidified, we can remove the comb, take the gel out of the mold, load it into a gel running apparatus that we fill with gel running buffer. Then we are ready to load our samples. Alongside our samples, we should also always run a ladder which has nucleic acid of known size and concentration so that we may estimate the size and concentration of our samples. Once the samples are loaded, the current is turned on and the DNA begins to move down the gel. The loading dye that is mixed with the samples includes a dye that will allow us to track the migration of our samples as they progress through the gel. It is also dense such that the samples sink to the bottom of the well when loading and thus do not diffuse away into the buffer. Once loaded, we turn on the current and wait until the dye front is almost to the bottom of the gel. In order to visualize, we must put the gel under UV light in a gel imager. We then see our DNA in our samples.